The video lesson for position time, velocity time, and acceleration time graphs. The learning target for this lesson is I am learning to describe the motion of an object using position time, velocity time, and acceleration time graphs. The success criteria for this lesson are I can describe the behavior of an object based on its position time graph, I can describe the behavior of an object based on its velocity time graph, and I can describe the behavior of an object based on its acceleration time graph. Okay, so here we have a video of a cart rolling across a track to show constant motion. You can see that the cart is slowing down just a little bit as it goes. It's pretty hard to show constant motion, or pretty hard to make constant motion. Okay, and here is the graph of the motion using a motion detector. It's got a position time graph, velocity time graph, and acceleration time graph. And I'm going to pause it right here. Okay, so you can see here that we have a pretty constant slope for the position time graph. So on a position time graph, positive motion equals a positive slope. If we had a negative slope on the graph, so if the slope of the graph looks like this, we have a negative slope. Negative slope, that would mean negative motion. The object would be going in the opposite direction. So since we have positive slope, that means the object is going in a positive direction. Since we have, if here as another example, if we had a negative slope, we would have negative motion. The car would be going in an opposite direction. If we had, say right here, where we have a zero slope, so right here we have zero slope, we have zero motion. At that point, the cart is just standing still. Now, if we look at this part where we have velocity versus time, so here at velocity versus time, at this point where we have zero motion, we have a zero velocity. During this point right here, from here to here, our velocity is changing a little bit. If we had completely constant velocity, we would have a flat line. So constant velocity would equal a flat line, or let's say no slope. Instead, in actual fact here, the car is slowing down a little bit. So we have a negative slope. Notice though that all these numbers on the y-axis, these are all positive numbers. So that means that the cart is moving in a positive direction. If the cart was going in a negative direction, so if the graph instead looked like this, so this is zero, this is negative, this is positive. If the motion looked like that, then the cart would be going in a negative direction. And then finally, we have our acceleration versus time graph. So acceleration versus time. Okay, so we have all this messy stuff over here, but what we want to look at is this area right here to right here. So in this area, we see that we've got, if we zoomed in a lot, we would see that it's basically just a little bit below zero, just barely below zero. And it's constant. So that means we're just barely accelerating. So we have a negative acceleration. Very small negative acceleration. So we have a very small negative acceleration. Here's an acceleration time graph. So that's acceleration versus time. If the graph were just right on the x-axis, then we would have no acceleration. If the graph were up here, we'd have positive acceleration. And like in this case, the graph is just barely down here, we have negative acceleration. So this is what a position time graph, velocity time graph, and acceleration time graph shows you. All right, so what have we learned in this lesson? So we've learned about position time graphs. The slope translates to the direction of the motion. So a positive slope means that we're moving in a positive direction, and a negative slope means that we're moving in a negative direction, and a constant slope means that we have constant motion. On a velocity time graph, the slope translates to the acceleration. So if we have a positive slope, we have positive acceleration, and a negative slope means we have negative acceleration, and no slope means that we have constant velocity. And then finally, acceleration time graphs. So constant acceleration has no slope. So if there's no slope in an acceleration time graph, that means that the object is moving at a constant speed. And if we have positive acceleration, that means that the velocity is changing in the same direction that the acceleration is going. And if we have negative acceleration, that means that the velocity is changing opposite to the acceleration. All right, everybody. Thank you.